Okay, so in this next video, we're still got some radicals that have, or equations that have only one radical, but there's some slight differences. Things get a little tougher, and we just have to be aware of items. So in letter C, the good news for us is the radical is already isolated. So to clear it, I'll square both sides, and then here's where we have to be careful. Right, on this side, we end up with 1 minus x because the radical clears out with a square. But over here, what we actually have, right, is a sum being squared. So we technically have x plus 5 times x plus 5, or what's commonly known as a perfect square trinomial. All right, and so when we FOIL this out, when we go through all our foiling, we're going to end up with x squared plus 10x plus 25 as the resulting equation out of all that. So classic perfect square, x times x is x squared, 5x and 5x gives us 10x, 5 times 5 is 25. So right there, be very careful. We are squaring a sum, and it's not as easy as just squaring each piece and then adding it. It's actually multiplying it out, foiling it out. But the resulting equation now is a quadratic. All right. So the way we can solve a quadratic, there are several. Right. We can complete the square on it. We could use a quadratic formula. We could factor, all that other good stuff. So I'm going to try to factor this. So to factor it, what I need is one side equal to 0. So my balancing act will be to add x and subtract 1 from both sides. That gives us x squared plus 11x minus 24 is equal to 0. So if I factor this, I believe it does factor. I think we're looking at x minus 8 and x minus 3. I'm going to use the guessing and check method to get there. Let's see, does that work for us? Oops, this would be a plus 24. All right, yeah, 25 take away 1 is plus 24. So that should work, right? First times first is x squared. Last times last is a positive 24. My outer and inner is a negative 8x and negative 3x, giving us positive 11x. So there we go. So I now have the zero factor property. So maybe the x minus 8 is equal to 0. Or maybe the x minus 3 is equal to 0. And adding 8 to both sides, we get a solution of x equals 8. Adding 3 to both sides, we get x equals 3. All right, now again, remember, these are potential solutions. We still have to go back and make sure that they actually work. And so when I plug an 8 in here, right, what we actually get is 1 plus 8, or excuse me, 1 minus 8, which gives us the square root of negative 7, which is no good. So that is extraneous. If I try putting a 3 in there, right, 1 minus 3 gives us a square root of negative 2, which also is no good. So that is also extraneous. So unfortunately, despite all this great math work that we did, clearing radicals, working with quadratics, the equations that the possible solutions that come up, neither one of them work. They're both extraneous. And since these are the only ones that came up, that actually means that this equation has no solution. All right, so kind of tough luck for us. So all that good work, and what we got, both answers were extraneous. The math gave us nothing else to try. So that one actually has a no solution case. So a lot of kind of some pretty wild stuff in that one. All right, so next one, again, we have one radical. But to isolate it, how about I add that radical to both sides? That'll be the move I do there. So I get x minus 2 equals the square root of x minus 2. And so to clear the radical, I'm going to have to square both sides. Okay. Again, over here, what I have is a perfect square trinomial, x minus 2 times x minus 2. And over here, my x minus 2 cancels out. Alrighty, and so over here, if I multiply this out, I will end up with that, x squared minus 4x plus 4. And it's a quadratic, so how about I move everything over to this side, and we end up with x squared minus 5x plus 6 is equal to 0. So factoring that, I believe that factors as x minus 3, x minus 2, right, equals to 0, right? So the negative 3x, negative 2x, yeah, so we got that. So x minus 3 is a potential solution, x minus 2. So if I add 3, we get 3 as a possibility. If I add 2, we get 2 as a possibility. So to check them out, I plug them in. So if I plug in a 3 here, right, let me go ahead and do this. We get 3 minus 3 minus 2 minus 2. Does that equal 0? Well, that's 3. This is the square root of 1. And we get 3 minus 1 minus 2. That's 0. So that actually checks out. If we put a 2 in there, 2 take away 2 is 0. So the square root is 0. 2 take away 2 is 0. So that also checks out. So as we were really unlucky on this one, we're extremely lucky over here. So both answers that I created, right, both actually solve it, and they both actually solve the equation. So kind of good luck on our part there. There are some where one will work and one doesn't. So be aware of that, but that's kind of going back to the idea, because we're going from a situation that has restrictions, square roots and negatives aren't good, to a situation that doesn't have any restrictions, right? Parabolas are very nice, their domains, everything. We have to be careful about the solutions that we get for the parabola might not actually work for the radical. So we got to be aware of those extraneous solutions. This one is extreme, right? Both were extraneous, nothing worked. Here everything worked out. And then there are those cases where one will work and one won't. So be aware of that as you do some of your homework and you work through that. So how about I stop the video there? We're done solving equations with one radical. Now we got to go look at situations when I have two. All right, but I'll cut a new video for that information. See you guys there.